Welcome back to the deep dive. Today we're digging into something pretty significant that just went down in the AI world. We're talking about the big shakeup at Meta's AI department back in October 2025. Specifically, the layoffs hitting their superintelligence laboratory.
Yeah, and this isn't just about, corporate musical chairs. We've got insights from someone right at the heart of it. Tian Yuandong, he was the research director at FAIR Meta's Fundamental AI Research Lab. The irony, of course, is FAIR was huge on scaling models.
Right, and the context here is really important for how you interpret his thoughts. It wasn't quite a surprise layoff for him personally. He had actually already told his manager he was planning to leave. So this whole thing basically just sped up his exit.
Exactly. So what we're getting is this really unfiltered, high-level critique from someone who was just inside. He's looking at big tech's main AI strategy, the scaling path, and saying, maybe this isn't right. And he's not hurting for options now, apparently getting tons of offers. So he can really speak his mind.
Definitely speaks from a position of freedom then.
For sure. And his critique lands because he was part of that scaling world. He wasn't just an outsider throwing stones.
Yeah.
Our goal here is to really break down his thinking on the big picture trends driving all this.
Okay, let's start with that first big idea he flagged. He doesn't see these layoffs as just a meta thing. He calls it an industry-wide macro trend, the automation paradox, which sounds, paradoxical. AI creating jobs, but also AI engineers getting laid off.
Well, yeah, the paradox is kind of baked into the process itself. AI development, by its nature, automates. Well, AI development. As the models get better, they actually reduce the need for certain kinds of human labor involved in building them.
So the very thing they're building is making parts of their own jobs obsolete.
That's the core of it. Think about the early days. You needed huge teams doing manual stuff, right? Labeling data, checking quality, tedious work. But the newer, stronger models, they can handle a lot more of that data prep and cleaning themselves. And on the engineering side, the tools, the pipelines, they're just way more sophisticated now. Less need for constant manual fixes, that sort of firefighting.
Okay, so that definitely changes the game for certain roles, people doing the more routine, execution-focused stuff. What does he see as the end result of this trend for you listening, maybe thinking about a career here?
The big shift is away from those roles focused on just like running the standard playbook, training models with existing methods. You just don't need as many people for that anymore. Instead, the demand surges for two other kinds of people. One, folks doing truly exploratory boundary-pushing research, and two, people applying AI in really deep, specific vertical areas where, human creativity and domain knowledge are still absolutely key. It's less about being an operator, more about being an innovator.
That really clarifies the shift in the workforce. Okay, so if execution is automating, let's talk about the models themselves. His main critique seems aimed squarely at large language models, LLMs. He calls them an interesting path, which sounds polite, but then he questions if it's the correct path. What's the biggest sticking point for him?
It really just boils down to efficiency, or maybe the incredible lack of efficiency. It's the absolutely mind-boggling amount of data these things need. That's the crux of his argument. We're talking, what, 10 to 30 trillion tokens for training these foundation models?
30 trillion. It's hard to even picture that number.
It is, and he puts it in perspective. Compare that to a human. Over an entire lifetime, you might encounter maybe 10 billion text tokens, maybe. Yet we produce incredibly creative scientists doing truly original work from that relatively small amount of data. So you've got this huge gap, like 1,000x difference in data efficiency, humans versus current AI.
Wow. 1,000 times more data, more energy, presumably. For what kind of performance gain?
Well, that's the thing. It leads to his really stark conclusion about the current scaling law. This idea that you need exponential jumps in data and compute power just to get sort of linear improvements in what the model can do. He calls that a pessimistic future.
Pessimistic. Okay, I get that it's inefficient. But big companies have deep pockets, right? They seem willing to pay the price if the scaling works. Why is the cost itself a fundamental flaw in his view?
Because he thinks it's not just expensive, it's potentially unsustainable for, like, the whole planet. If you follow this scaling logic all the way to artificial general intelligence, AGI, he raises the possibility that just training these ever larger models could literally start consuming all the available compute resources, all the energy on Earth. It stops being just a budget line item and becomes a resource constraint problem, a physical limit.
Okay, so the argument isn't just it costs too much money. It's that brute force computation hits a wall. We fundamentally need smarter algorithms, better learning approaches, not just bigger machines.
Exactly. Scaling becomes a kind of trap if it stops us looking for those real algorithmic leaps.
Mm.
It's like paving a road with data, but you might just run out of planet to pave it on.
So if scaling is the pessimistic road, where does he see more promise, the smarter path? He seems pretty keen on reinforcement learning, RL. How does that differ fundamentally from, say, supervised fine-tuning, SFT, which we hear a lot about? Why is RL more fundamental?
Okay, let's use an analogy. Imagine you're learning, I don't know, advanced physics. SFT, supervised fine-tuning, it's kind of like cramming for a test by just reading the textbook over and over. You passively absorb all the known stuff, the data. You might get good at spitting back examples you've seen, memorizing proofs, but you could struggle with a truly new problem.
Right, it risks just being good memorization.
Exactly. Now, RL, reinforcement learning, that's more like being given a bunch of unsolved physics problems. You get to try things out, experiment with different approaches, and you get immediate feedback. Did that work? Did it get closer to a solution? It's active learning. It's a search process. RL actually guides itself towards useful data by trying to solve hard problems. That data is often much richer than just passively reading everything.
That makes sense. Active problem solving versus passive knowledge absorption. RL learns how to reason, maybe, while SFT learns what has been reasoned before.
That's a good way to think about it. That active search part is why he argues RL gets closer to genuine reasoning and generalization. The model isn't just retrieving information, it's building the capacity to tackle things it hasn't explicitly seen before.
And he has some firsthand experience with the limits of even the best current models, right? He seemed to agree with the view that we're maybe in a decade of progress towards AGI, not like next year. And he co-authored a paper using GPT-5, which sounds cutting edge. What did that teach him about the gap that still exists?
Yeah, the experience was telling. GPT-5 apparently did a great job with the complex math, the formulation side of the paper.
Mm-hmm.
But, and this is the key part, it absolutely needed human insight, that deep domain expertise, to prevent the paper from being, well, fundamentally flawed or just unoriginal.
Flawed how? Can you give an example? What did the human expert catch?
Well, the model could generate mathematically correct stuff, sure, but it lacked the context, the history of the field. For instance, the scientist, Tian Yuandong, had to intervene because the model was exploring an idea that looked solid mathematically. But it was something that had actually been proposed years ago and shot down for physical reasons the model just didn't understand. The AI couldn't judge novelty or real-world feasibility. That still required the human expert's taste and knowledge of scientific dead ends.
Wow. So the human is still crucial for steering, for originality, for knowing what questions are even worth asking.
Absolutely. It highlights that even SOTA models today need that human judgment to avoid going down rabbit holes or reinventing the flawed wheel. They're powerful tools, but they still struggle to have that truly inventive spark, especially with limited data.
Okay, let's pivot a bit to the business side of things. He came from FAIR, known for its big, centralized research model. Given Meta's own push with Llama, does he see a future dominated by closed-source giants, or is there real space for open source?
His take is pretty nuanced. It really depends on why you're building the model. What's its purpose?
Yeah.
And yeah, Meta's Llama strategy fits right into this. Open source, you mentioned projects like Reflection, work from AI to open source shines when your goal is to build an ecosystem, a community, a platform, a general tool set.
Mm-hmm.
That seems to be Llama's play, right? Enable lots of other people to build things on top.
So is Meta going open source maybe a tacit admission that trying to build the one giant closed model is just too costly, or like he suggests, maybe even a dead end for general intelligence right now?
It could suggest that, yeah. Or at least an acknowledgement that the best immediate business value might be in owning the platform, not hoarding the core tech itself.
Right.
On the flip side, he says proprietary closed models make total sense for very specific focused tasks. Things like personalized search, recommendation engines, where the secret sauce is your unique data, and fine-tuning for your internal needs. So both approaches have their place. Open source could really bloom in lots of specialized areas.
Interesting. And thinking about his own journey at FAIR, he mentioned developing something he called research taste, especially after 2018. What exactly is that, and why should, someone listening care about getting it?
Yeah, this felt like a really crucial piece of career insight. He actually admitted that earlier on, say 2015 to 2018, he was very engineering focused, wrote a lot of code, and apparently he even got some criticism back then for not publishing enough traditional academic papers.
Too much code, not enough papers. That sounds kind of backward for an AI lab today.
Doesn't it? But his point was, his real breakthrough came later, when he consciously developed this research taste. It's not just about technical skill like writing code or solving a tricky math problem. It's a deeper intuition about the field. It's the ability to look ahead and identify which research directions are truly important, which problems matter long term. It's knowing the difference between a hard problem that's maybe irrelevant and a hard problem that could unlock the next 5 years of progress.
Okay, so how do you actually cultivate that? Is it just experience?
It seems to be a mix. Deep knowledge, yes, but also critical thinking about where the field should go, reading widely, questioning assumptions, and critically, he implied, knowing when to stop pursuing something, even if it seems promising technically, if it's leading down a dead end strategically. It's about setting your own direction for impact, not just following the crowd.
That makes sense, especially if the field moves as fast as it does. We've seen deep learning, transformers, LLMs all emerge pretty rapidly in, less than a decade. So how should someone starting out or even mid-career think about navigating that rapid change?
His advice here was really pragmatic, basically. Don't just chase whatever skill seems hottest or most scarce right now, because the cycle time is shrinking. It used to be maybe 10, 20 years for a paradigm shift. Now, much faster. By the time you reskill for today's hot thing, the goalposts might have moved again, leaving you behind. Instead, he suggests focusing on two things. First, what do you actually find fundamentally interesting? What do you want to work on? And second, combine that passion with a realistic long-term judgment. Is this skill set likely to be valuable in, say, 10 or 15 years?
That's a tough balance.
Yeah.
Passion plus long-view pragmatism. Okay, last big question then. What about the future of those big, idealistic research labs? Places like FAIR was perceived to be. Are they dinosaurs?
He's pretty realistic. He thinks those highly visible, centrally funded institutes, the ones needing massive budgets and promising huge near-term breakthroughs, they might struggle, especially under corporate pressure when the scaling path gets super expensive or it hits diminishing returns. But he's actually optimistic about research freedom continuing. It just might look different.
Different owls.
He uses this great phrase, guerrilla warfare. He pictures impactful research carrying on, maybe in smaller, more focused teams, possibly embedded within larger companies or in specialized startups. Groups of dedicated idealists tackling specific important problems, maybe without the pressure of having to deliver the next giant all-purpose model immediately. Research driven by conviction, not just hype.
And his own next steps seem to reflect that, right? He hasn't decided exactly what's next, but he's looking for something that mixes research and real-world application, even talking about automating parts of the research process itself.
Yeah, and his final advice kind of sums it up. If you want to make a big difference, aim for an impossible goal, then work backward. Which ties right back into that idea of research taste, doesn't it?
Yeah.
Don't just solve the obvious next step. Define the truly hard, seemingly impossible problem, and then figure out how to start chipping away at it.
So wrapping up today's deep dive, we've really explored this core tension in AI, this choice the industry seems to be facing. On one hand, the scaling path powerful, proven up to a point, but potentially resource-hungry and, as he puts it, pessimistic. And on the other, this search for more efficient, insight-driven active learning. Trying to close that thousand-fold efficiency gap compared to how humans learn. It's fascinating that a former director from a lab so central to scaling is now arguing the future has to lie in smarter algorithms.
It really frames the challenge ahead, doesn't it? It suggests the next big leaps might come from algorithmic ingenuity, not just bigger hardware stacks.
Definitely.
Yeah.
Which leaves us with a final thought for you to consider. If that scaling law really is unsustainable, if it can't fully capture how humans make those creative leaps, and if human insight and taste remain a bottleneck, what else is needed? What non-computational resource beyond just human experience might be the key to unlocking the next truly fundamental breakthrough in artificial intelligence? Something to chew on until our next deep dive.